Good evening, students. In the previous class, we have seen up to this question: how many sigma and pi bonds are present in the each of the following molecule? This example we have seen in the previous video. So now, in this class, in this video, we will see remaining two questions. That is, what is the type of hybridization of each carbon in the following compounds? So here he has asked, in these compounds, five compounds are given: methyl chloride, acetone, acetonitrile, and formamide, and this one some other compound, organic compound. Okay, so IUPAC nomenclature we can write this name. So one by one we will see what is the hybridization in each of the following compounds. The first compound given is CH3Cl. CH3Cl. Now this CH3Cl, we will write the structure, we will expand the structure like Cl, like this, and here H, here H, here H. So carbon is having all single bonds. Carbon is having all single bonds. If carbon is having all the single bonds, then it is sp3 hybridized carbon. sp3 hybridized carbon. And the structure is tetrahedral structure. Tetrahedral structure. So when carbon is undergoing sp3 hybridization, the forming structure is tetrahedral structure. That's what we discussed in the previous classes. Okay, next one, next compound, if you see this one, that is B, CH3 double bond, means CH3 twice CO, CH3 twice CO. So if we write for that one, so here first we have to write this carbon and write the double bond here, and this side CH3, this side CH3, this one. So if we expand this structure like this, the structure will come like this. So this is nothing but acetone. This is acetone molecule. So here one more IUPAC name is there. This is common name. Acetone means common name. IUPAC name is 2-propanone. Means propanone. Propanone is the IUPAC nomenclature for this compound. Now here this carbon is sp3 hybridized carbon, because if we expand this structure, it comes like this: H, H, H. This side also H, 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 like this. So this structure we can write like this. We can expand like this. So this carbon, three carbons are there here: one carbon, second carbon, third carbon. First carbon is having all four single bonds. This one, this one, this one, this one, all are single bonds with three hydrogens and one CO group. One CO group with three hydrogens. Yes. So all are single bonds means this is sp3 hybridized carbon. sp3 hybridized carbon. Okay, come here. This is also having three single bonds here. This is also single bond. That means total four single bonds. So this carbon also sp3 hybridized carbon. Okay. Now come to this carbon. Here carbon is having double bond O, double bond O. So obviously when carbon is having double bond, pi bond is there. One is sigma bond, one is pi bond. So it is sp2 hybridized carbon. sp2 hybridized carbon. So this is sp3, this is sp3, this is sp2 hybridized carbon. Okay. Another example we can see is here C, CH3Cn. What he has given? CH3Cn. Okay. So if we expand this structure, this comes like C, H, H, H. Here C triple bond. If we expand like this, so it comes like this by following the valency of the carbon. Everywhere valency of carbon should match, valency of hydrogen should match, valency of nitrogen should match. Nitrogen always forms 3 bonds. Carbon always forms 4 bonds. Hydrogen always forms 1 bond. So this carbon, if you take, all are single bonds. This side, this side, this side, all are single bond. So obviously all are single bond means this is sp3 hybridized carbon. And here one more carbon is there, that is having triple bond. That is having triple bond. Triple bond means obviously it is sp hybridized carbon. Double bond means sp2. Triple bond means sp hybridization. Okay, this is acetonitrile. This compound is acetonitrile. Acetonitrile or ethane nitrile. IUPAC name is ethane nitrile. Okay, that is third compound. And D, fourth compound is HCONH2. HCONH2. If we expand this structure, first carbon we have to write. See, here oxygen is there, double bond. Always oxygen is having two bonds, so double bond. This side hydrogen is there, and this side N is there. Here H, here H. Like this, the structure will be expanded structure for this formamide. This name is formamide. Formamide. So here only one carbon is available. This carbon is having double bond O. So when carbon is having double bond, obviously it is sp2 hybridized carbon. sp2 hybridized carbon. Okay. Now the final one, E, structure E. So that is CH3, that is CH3, CH double bond CH CM, CHCM. So this one, if we expand this structure, C, three hydrogens are there, H, three hydrogens are there. Here C, H, this H we have to write either down or up. Here double bond is there. Here also CH is there. C, either down or up we can write. Again single bond C, CN, C, CN is there. CN means obviously triple bond. This is the expanded structure for this one. You can see everywhere carbon is having four bonds. This carbon also 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 four bonds. And nitrogen is having three bonds, and hydrogen is having one bond. Okay, so like that, this carbon all are single bonds, so obviously it is sp3 hybridization. This carbon is having double bond here. Even though two single bonds are there, we have to consider double bond. Double bond means that is sp2 hybridization. Here this carbon also, this side double bond is there. So when double bond is there, it is obviously sp2 hybridization. And here this carbon is having triple bond, three bonds, triple bond. So obviously it is sp hybridization. So like that, each carbon we can write the hybridization. Okay, so that is the answer for that question asked here. Here. So now another question is, write the state of hybridization of carbon in the following compounds and shapes of each of the molecules. So here problem number 12.3, A, if we write, it is given CH2 double bond O, CH2 double bond O. First we have to expand this structure. How to expand? First you write C, and this double bond you have to write like this, and both the sides of carbon, two hydrogens you have to write like this. So this is formaldehyde. The name of the compound is formaldehyde. Formaldehyde. So obviously this carbon is having double bond, so it is sp2 hybridized carbon. sp2 hybridized carbon. So when sp2 hybridization is there, obviously the structure is planar trigonal structure. Planar trigonal structure. For sp3 hybridization, it is tetrahedral. For sp2 hybridization, it is planar trigonal. For sp hybridization, it is linear structure. So that we have to remember. Okay. The second question is, second bit, CH3F. CH3. Obviously, CH3F means first write carbon. Above I am writing fluorine. Here H, here H, here H. All are single bonds. All are single bond means obviously it is sp3 hybridization. sp3 hybridization. When sp3 hybridization, obviously it is tetrahedral structure. Tetrahedral structure. Okay. C. C is HC triple bond M. So if we expand the structure HC triple bond M. So this carbon is having three bonds. So obviously it is sp hybridization. sp hybridization. When sp hybridization is there, it is linear structure with bond angle 180 degrees. Bond angle 180 degrees. Here bond angle is 109.5 degrees. Here bond angle is planar trigonal 120 degrees. So like that we can write the shapes and hybridization of the compounds he has asked. Okay. So this page is over. Now we will go to next page where uh, it is given. So structural representation of organic compounds. Complete structure, condensed structure, and bond line structural formula. So complete structural formula, condensed structural formula, bond line structural formula. So if you read this paragraph, you will see first Lewis structure. If we take the example of methane, like this, CH4 methane. So Lewis structure for this one is Lewis structure. If we write for this methane, then we can write like this: H H H H H. So this kind of representation of methane is called Lewis structure. Lewis structure. So if we represent the methane like this, H H H H, like this. Here bond like this. This single bond, single bond, single bond, single bond. So this is called dash bond, dash structure, dashed structure, dashed structure. And this one is called, this type of representation. This type of representation is called condensed structure. Condensed structure. If we have to write a condensed structure for ethane, this is ethane condensed structure. Ethane. This is methane condensed structure. This is ethane condensed structure. And if we have to write a condensed structure for propane, then we have to write CH3, CH2, CH3. This is condensed structure for propane. Okay. So this is another representation. So this type of representation is called Lewis structure, where bonds are represented by dots. This type of representation is called dashed structure. This type of representation is called this one type of representation is called condensed structure. And one more structure is there, that is bond line structure. That is bond line structure. So if we have to write a bond line structure for propane, CH3, CH2, CH3. This is propane. Okay. So bond line structure is just simply like this. This is also propane. This is propane. This is also propane. If we have to write for butane, CH3, CH2, CH2, CH3. This is butane. So bond line structure is this. So here CH3, CH2, CH2, CH3. So this is butane. If we have to write pentane, CH2, CH3, then this is pentane. This one and this one same. So it is just a representation. This CH3, the corner dots, corner uh, atoms are CH3. This is also CH3. This CH2, CH2, CH2. So here carbon is having one bond. So remaining three bonds are hydrogens. Like that. This is bond length structure. Okay. Excuse me. So complete structures. Complete structures means if we have to write complete structure for this propane. For that propane, the complete structure is complete structural formula is carbon, hydrogen, 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 carbon, hydrogen, hydrogen, carbon, hydrogen, hydrogen, hydrogen. This is complete structural formula for propane. This is condensed structure. This is bond length structure. This is complete structural formula of propane. If we have to write for butane, complete structural formula, butane, then this is the CH3, this is H, H, this is H, H, okay, and this is H, H, H. This is butane, complete structural formula, butane. So that can be written like this. Like that you can write for this pentane also, hexane also, heptane also, octane also. You can write a bond length structure, condensed structure, and complete structural formulas. Okay. So dash structures. So uh, here he is telling uh, this methanol structure is also given. Methanol. Here methanol structure is given. So heteroatoms, methanol, in methanol oxygen, in organic chemistry, oxygen, nitrogen, sulfur, halogens, these are all called, these atoms are called heteroatoms. Nitrogen, oxygen, halogen, sulfur, other than carbon and hydrogen. Hmm? Those are called heteroatoms. Those heteroatoms are having lone pairs. Those heteroatoms are having lone pairs. You can write, suppose methanol structure, if we have to write, then it is CH3OH. This is condensed structure. And the bond length structure is this CH3OH. In carbon and hydrogens, we do not have to represent. This is bond length structure. And complete structural formula for methane is like this: CH3OH. And obviously, always oxygen is having two lone pairs of electrons. Always oxygen is having two lone pairs. Neutral oxygen is having two lone pairs of electrons. Nitrogen is having one lone pair of electrons. Halogen is having three lone pairs of electrons. So, suppose if we write NH2 methylamine, then this nitrogen is having one lone pair of electron on nitrogen. If we have to write methyl chloride, this chlorine is having three lone pairs of electrons. Three lone pairs of electrons. So like that, oxygen is having two lone pairs of electrons. Nitrogen is having one lone pair of electrons. Halogen is having three lone pairs of electrons. Okay. These are the structural representations of condensed structure, bond length structure, fully complete structural formula. Okay. So we stop here. We'll discuss the remaining in the next class. Thank you.